Okay, we'll continue with the review. This is part 3 of test 2 review. We need an LCD because we're adding and subtracting fractions. So first thing we want to do is put a 1 underneath that 3, and we need to factor this as a difference of squares. So the LCD for this problem is going to be x plus 2 times x minus 2. So we need to build up each of these fractions. So 3 over 1, comparing 1 with the LCD, it needs both x plus 2 times x minus 2. And of course, if you multiply this out, you would FOIL it, which would give you x squared minus 4, and then distribute the 3, so you're going to get 3x squared minus 12 over the LCD. And that's one fraction. Now let's look at the second fraction, x over x plus 2. Comparing its denominator with the LCD, we have the x plus 2, we need the x minus 2, so multiply top and bottom by x minus 2. Distribute the top, gives you x times x is x squared, x times negative 2 is minus 2x. And that's the second fraction. And the third fraction already has the LCD. So now we'll write it out as a problem. So we get 3x squared minus 12 over the LCD plus x squared minus 2x over the LCD minus 2 over the LCD. Okay, remember with subtraction, we need to change this subtraction to addition and then change the signs following it from the numerator. So this is going to give us 3x squared plus 1x squared gives you 4x squared. Then bring the next one, which is minus 2x. And then combine like terms, minus 12 minus 2 gives you minus 14. And now we need to see if that simplifies any further. And this doesn't factor any further. We could take out the 2 from the GCF in the numerator, giving you 2x squared minus x minus 7 over the LCD, which is x plus 2, x minus 2. The 2 isn't going to cancel with anything on the outside, and 2 times negative 7 is negative 14. So what do you multiply to get negative 14 that you add to get negative 1? Well, there are no factors that will do that. So this is the correct answer. Or you could have had this answer with the LCD written out. Okay, number 18. Remember that these denominators are subtracting, so you need a common denominator, and these two are very similar. This is x minus y, this is y minus x. They differ by a negative, so we're going to flip this around, put the negative in the numerator, and then now they have the common denominator, so we'll write x minus y in the denominator. 3 minus a minus 4x is 3 plus 4x, which is 7x, and that does not simplify any further. Okay, number 19, another addition problem. Remember, you've got to have an LCD here, so we need to factor this. It's going to be factors of negative 20 that add to give you negative 1, or minus 5 plus 4. And that happens to be the LCD, because m plus 4 here is already included in that. So we want to build these up. Well, this fraction already has the LCD. This one needs it. So 2 over m plus 4. Comparing the LCD and the m plus 4 denominator, we're missing the m minus 5, so multiply top and bottom by m minus 5. Distribute the numerator, you get 2m minus 10 over the LCD. Now rewrite your problem. So we have m over the LCD plus 2m minus 10 over the LCD, and we combine like terms, you get 3m minus 10 over the LCD, which is m minus 5 times m plus 4. You need to see if that simplifies further, but it doesn't. There's no GCF factor that you can take out of the numerator, and nothing that's the same that you can cancel with the denominator. Okay, here's another complex fraction, certainly more complex than the ones we dealt with earlier, but the steps remain the same. We first need to write this as a division problem. Okay, the goal in a complex fraction is to always get this to be one fraction divided by one fraction. And you see the second fraction fits that bill, but the first fraction is not one fraction. So we need to get a common denominator here and build this up as a separate problem. So the LCD here is x plus 2x minus 5. So I'm going to look at the first fraction, comparing its denominator with the LCD. We're missing x minus 5. So multiply and distribute across. You're going to get x minus 5 over the LCD. The second fraction, 1 over x minus 5, needs to be multiplied top and bottom by x plus 2. Distribute the numerator, you get x plus 2 over the LCD. Do the addition, so I'm going to get x minus 5 over the LCD plus x plus 2 over the LCD. And when you combine like terms, you get x plus x is 2x, negative 5 plus 2 is minus 3 over the LCD. Now let's go back to the original problem. This is this fraction in one single fraction. So now we factor, flip, and multiply. So when we do this, no factoring to be done with that. The LCD is already in factored form. Change division to multiplication and flip and factor. This new numerator, factors of negative 10 that add to give you negative 3 are minus 5 plus 2. And here, factors of 2 times negative 3 makes that negative 6 that add to give you negative 1. So you'll end up multiplying this out using either double slide or one of the other methods. So you want this to go like this, and minus here, plus there. Alright, so let's cancel everything we can. The minus 5 and the plus 2 can go, also the 2x minus 3. You see everything canceled in the numerator, leaving you just a 1, and in the denominator you have x plus 1, and that's the answer. Okay, similar problem. We want to first write it as a division problem. Neither one is one fraction divided by one fraction, so we need to get an LCD. The LCD for this set is x plus 1, so let's build that up. 1 over 1 needs to be multiplied by x plus 1 over x plus 1, so you get x plus 1 over x plus 1. The other one already has that denominator, so this will be x plus 1 over x plus 1 minus 1 over x plus 1. And remember, change that to plus, change all signs following it. Combine like terms in the numerator and you get x over x plus 1. That's the first fraction simplified to one fraction. Now let's simplify the second fraction. The LCD here is x minus 1. So 1 over 1 needs to be multiplied top and bottom by x minus 1. Gives you x minus 1 over x minus 1. That's already got the LCD, so let's write it as an addition problem. So x minus 1 over x minus 1 plus 1 over x minus 1. Combine like terms, you get x over x minus. Okay, there's the second fraction. Now let's do the division. So you get x over x plus 1 divided by x over x minus 1. Factor, flip, and multiply. You'll see there's no factoring to do, so x over x plus 1 times x minus 1 over x. The only thing that cancels are the x's, leaving you x plus 1, oops, pardon me, that's an x minus 1 over x plus 1. And that's the answer.